All right, let's talk about a reaction called ozonolysis. Ozonolysis is a reaction, or it's translated as ozone cutting. We're going to use ozone to cut through a molecule. So here's a structure. We're going to react this with ozone. That's the first step. We will always have a second step in an ozonolysis. This is called the workup step. Ozonolysis is a little bit like serving pasta for a meal. Someone's going to say pasta. Well, what kind of pasta? Is it going to be pasta with marinara? Is it going to be pasta like lasagna? So you need this extra specification when you say ozonolysis. That's the workup. The workup it gives you the more specifically what are you trying to make. So we're going to form these products. There are two types of workup. One, there's the reductive workup. And you might be able to guess what the second was, is going to be the oxidative workup. Great. Okay, let's show both of these. So here's our alkene again. We're treating this with ozone. That should be a subscript. That's not very clear in the top one. And now we need to give the reductive workup conditions. There are several types of conditions. Dimethyl sulfide is a common one, or maybe more common is zinc and HCl. But these are just sources of electrons. What we get is this. So let's put this hydrogen in just to be explicit about it. We get these two products. What we've done is we've cut lysis, we've cut the alkene in half with ozone. And so when you do the reductive workup, there are two things to do. One, we're going to chop the pi bond. And really, let's be specific. The pi and sigma bonds are both being chopped. And two, we are inserting oxygens. Just insert oxygens. And so this gives us things like ketones and aldehydes, and whether we get a ketone or aldehyde depends on the substitution here in our starting carbons of our starting material. So that's a reductive workup. The oxidative workup is almost identical, with one twist. Okay, so the first step is the same. We treat with ozone. The second step, we're going to treat with oxidative conditions. So sodium hydroxide, hydrogen peroxide, and water. That combination of reagents, and we get something very similar. Ta-da, I drew another ketone, kind of boring. And it looks like I'm going to draw another aldehyde, but instead I've drawn an acid. So we get ketones and acids from this. So what are the steps for what to do when you do an oxidative workup? Well, we chop the pi and sigma bonds. Great. We insert the oxygens. And at the very end, we remember to convert any aldehydes become carboxylic acids. That is the oxidation step from the oxidative workup. So that's what we get when we do an ozonolysis. You don't see ozonolyses too often these days, but people do still perform them. We'll see what some alternative chemistry is to this kind of oxidative cleavage reaction, oxidative cleavage of the carbon-carbon pi bond.